Testing audio 1 2. Testing audio 1 2. Testing audio 1 2. Testing. Thank you. Okay, good afternoon, everyone. We'll wait for 2 more minutes just to get the live stream audio sorted, and we'll start after that. Okay, I think we can get started now. So, welcome back to week 7. I hope you all had a well-deserved break and an opportunity to refresh yourself. Turnout is slightly lower this week, which is very common. In the lecture itself, we see more people on the live stream. I guess it's because of your assessments which are due end of this week. And probably some people are still getting back to study mode after the break, right? Nonetheless, let's get started with week 7. We'll start, like we always do, with some class announcements, just to refresh yourself about what's happening this week. First of all, you must have already seen in the newsletter posted on Monday morning that there are no practical lab tasks for this week, right? So you don't have to stress about doing a lab task, but the lab sessions will still go on, right? So what this means is it provides you an opportunity to catch up with things probably you are behind on over the last 6 weeks. It's also an opportunity for your groups to meet because a major assessment is due this Friday, right? And usually maybe some of your friends or your team members might have issues meeting up at an alternative time. So this is basically a time slot where your entire team, your 4 or 5 teammates will be present. So you can utilize this lab hour or lab session to basically do your team meetings and work on your projects if there's any aspect of the project that is left. Also, you can use this to get some feedback from your tutors. They can also help you guide you in terms of your progress on the assessment. The other thing normally which is due every week is the quizzes, right? So we'll still have your normal theory quiz due for this week, but just note that the due date for that is next week, Monday, right? So you can attempt it anytime this week, or you can attempt it after the due date for your project, that is in the weekend, right? As long as it's submitted by 8 p.m. Monday morning, you are still, that's all still fine. Also, we took a poll last week just to get a sense of how many of you wanted a second lecture that is on Thursday. Like I said, because of attendance. So 90% of the students said that they preferred only one lecture and they wanted to spend the time, that slot for the second lecture working on their project. So we listen to you. So this week there's only going to be one lecture, but from next week onwards, we'll have your normal 2 lectures per week on Tuesdays and Thursdays. Any questions or concerns so far? No? All clear? Yes. Now about your iteration 2, there's only 4 more days to go, due at 6 p.m., so make sure you try to meet the deadline. As software engineers, deadlines are very important. Sometimes they are hard to meet, so that's why we have some flexibility in terms of less practical work this week in the labs. But make sure you try to submit the project on time. Also, we'll have some previews going on this week. If you refer to section 8.2 of the project document, you can see the different times these previews would be run. And the idea of this preview, and I emphasize that, is to give you some early feedback. Sometimes students have a reasonable project, but when they submit, when we run our test cases, it fails all the test cases, right? And you end up getting maybe 0. So this is an opportunity to submit a partial working version of your project early, get some feedback as to whether you are on track, and avoid getting that 0 mark for your project, right? We won't give you an exact mark when you submit your test runs. However, you'll get some idea of whether you are doing very well, average, or it's below our expectation. Now, these previews or early feedbacks are optional, right? So you're not obliged to submit it, but you can check that option when you make the submission, and then you can get some feedback and quickly tweak things around before the Friday deadline. Right? And also, you must be sensing that there would be a change of lecturer from next week. Over the past 4 weeks, you have had me. From next week, we'll have Dr. Yushao Jiang, who will take over the last few topics of the course. We will still be part of this course, and we'll maybe see you again in week 10. But Dr. Yushao, she's the course governor. She's an experienced lecturer. I'm sure you'll have a great time with her as well. So that's the slight change that you'll see in terms of the face standing in front of the podium from next week. Now, in terms of today, this is what we're going to focus on. Briefly, we'll try to recap what we have learned over the past few weeks and where they fit in for your project. For example, HTTP servers, right? We have seen that from iteration 1 or the first 4 weeks of the course was focusing on standalone application where you just run the program on your single machine. Then you shifted to a client server-based system. So you had a web server, and then your application, the core application was running on the back end. Then we learned about advanced function. Anyone can recall what we learned in advanced functions topic? First class functions. What are first class functions? Yes, so these functions can be assigned as variables, and what that helps us do is pass these functions as parameters, right? Or these functions can also be returned by other higher order functions, right? So that's the benefit of using those advanced functions. In advanced functions, we also learned about anonymous functions. Anyone recalls what those are? Yes? Right, we learned about arrow functions, right, which is a very simplified notation. That arrow function can have a named, right, or it also can be a function without a name. When do we use anonymous functions? Yes. Yes, so if there are some functions normally which you use just once in your code, right? You don't have to declare them or use them put them separately or give them any special privilege. They can be just used as anonymous functions called within other functions straight away, right? So that's when we use anonymous functions. Then we learned about persistence. Anyone can recall what persistence is all about? I know this was before the break. Maybe there at the back. Yes. So most of the times when we run standard programs, we declare variables, and this data is just temporary, right? But when we stop this application or the application crashes, the data, the traces of whatever was created or deleted or updated is lost. So persistence allows us to have an additional layer in your application. We call it the data layer, where data can be more permanent. And there are multiple common ways of making things permanent. The most common is to use a database, but that's not beyond the scope of this course. So we used a simple approach. We used a simple file, in our case, a JSON file, to store this data, to give some kind of permanence to the data. Then we learned about code coverage. What was code coverage? How much of the code is tested, right? What does this metric actually help us understand about our code?
Like how efficient it is.
How efficient our code is. So if you get 100%, does it mean the code is perfect?
It does not mean necessarily, but that means that the system tells you that yes, you've covered all bases of the code in the test.
Right. So whatever logic was correct. So if you get a high percentage, it means whatever logic was implemented in your code to some degree or to a higher degree has been verified. Right? So that's what the coverage means. But it doesn't mean it's foolproof or perfect. It's only to what degree it has been verified. There are some special numbers or metrics we get from code coverage. What are those? Can you recall what are some of the metrics that code coverage provides us? It gives us branch coverage. Anyone knows what branch coverage is? Right? If else, or different conditional options that have been executed. So sometimes you have to make decisions in your program. When you test your code, you have to make sure all those decision pathways are tested, right? Only then you can be confident of deploying those applications. So that's branch coverage. There was another called statement coverage. Gives a percentage. What does statement coverage provide? Maybe from this side. Yes? Okay. So your code is basically made up of a number of statements, right? You have print statements, console.log in JavaScript's case. You have declarations, you have conditions, you have assignments, right? Variable assignment, computation. All these statements can exist maybe on multiple lines or on the same line. So you want to test how many of these statements have been executed during your test runs, right? Your test cases. Right? Sometimes certain statements are skipped because maybe they are inside of certain branches. So this metric, statement coverage, provides you an indication of what percentage of those statements have been executed. There's another one. Function coverage, yes. And what is that?
How much of the functions are ran and tested?
Yes. So in your application, you will have not just a single function, multiple functions, right? If you're using HTTP server, you'll have multiple endpoints or routes, right? You have get, post, delete. So you want to make sure these different functions are also tested. Right? So if your code is only testing one function, that means some other functionalities are overlooked. So that's function coverage. There's one last one. Anyone can recall? Line coverage. Right? So this kind of sounds or feels similar to statement coverage, but remember, one line of code can also have multiple statements, right? Also in arrow functions, you might have multiple statements condensed together. So in that case, these two metrics are basically slightly different, right? So line coverage is if your code has 1,000 lines, have all the lines been executed during your tests, right? But there will be certain lines which will have multiple statements, right? So it gives you a slightly different measure. And the last one is metrics, sorry, not metrics, exceptions, right? What are exceptions when you write your code? Yes.
An error,
Error?
basically, in some statement or function in throw when something goes wrong.
Yeah, so when we write code, there is bound to be some errors, right, caused by some extreme cases. For example, you have a function calculating the square root, and someone or some user enters a negative number. Or you have a function where you expect a number as an input, but someone types a string or a character, right? So this can cause problems in your programs. What kind of problems can this cause? Can stall your program, crash your program, isn't it? And we learned how we can handle them very gracefully. What are some of the approaches we can take if we have exceptions? If you do nothing, what will happen? Crash, right? And you don't want your server to crash or your program to hang forever. So that's one problem. What can you do then? Try catch, right? So if you sense that there is some user input or maybe some API will return something which can be problematic, right? Enclose them in a try catch block so that the program can handle it automatically. And if in any case the input is not suited to what the requirement was, it will throw an error, right? It can be a custom error which you can write down or display yourself, or it can be a system generated error as well, right? So try catch. Yeah, so those are some of the important topics we have learned so far. The reason why I'm recapping that is most of those, please try to have them evident in your submissions this Friday. I think certain things might be used later on. For example, persistence and other things are not a direct requirement this time around, right? So from now onwards, when you make your submission or write your code, keep in mind how you can make your code more simplified using advanced functions. How can you test your code using the approaches and metrics we learned about code coverage and so on. Right? Any questions on that? Yeah, I'm just going through the live stream messages. I think we have answered most of them. So I guess we can progress through. But if there's something I have overlooked, maybe I'll cover that during the break. Now today what we'll focus on is conceptual modeling. So our focus will change a little bit away from coding to design, right? Which will be quite important for your next iteration as well. Normally design comes before coding. In week 1, 2, we learned about the waterfall model, if you recall, right? What are those stages of the waterfall model? When you build a software, what is the first step?
Requirement gathering.
Right? Requirements engineering or requirements gathering or requirements elicitation. Second step? Yes, yes, which is pretty much requirements gathering itself, right? After you have gathered those requirements, after talking to the stakeholder, what do you do next? Yes. Okay, so you do systems design. What do you do in systems design normally? There's a step before design, you do analysis, right? Remember, there's times where you may not be able to fulfill every need of the client, right? So in your analysis phase, you do those feasibility and other things to ensure that what the technology can deliver can be aligned to what the end user expects, right? Or the stakeholder expects. So that's the filtering process where you do analysis. Then you go into design. Anyone knows what happens in design?
Creating an architecture and technical.
Yes, so we look at the architecture, we do some kind of modeling of what the system will look like. After design, what do you do next? Implement, which involves coding, which you have been doing for the last 4 or 5 weeks, hands-on doing and implementing, right? And after implementation, yes, testing. Yes, so once you build something, you test it, and after that you maintain it, right? Because the software is not usually made for one-off use. It's made for the user's need over multiple, maybe decades, right? Facebook, once it's built, it's maintained. You have patches, updates coming up every few weeks, right? New features are added, features are removed, and so on. Likewise, Google's platforms, Microsoft's platforms, all of these evolve, right? So it has to be maintained. So you'll notice that modeling or design comes before development. So what we'll focus in today's lecture is how can we use models to simplify complex system ideas, right? And also a little bit focus on authentication. That will be the second half of the lecture today. And then if we have time, there was a question posted last week on the online survey. Someone wanted to know, how do we do coverage test for our HTTP server? Is there anyone here who tried that already? Yes, right? There are multiple approaches. What I'll discuss is one simple approach which you can use to test your HTTP server. Like I said, there are other approaches which are discussed in your labs as well. So you don't have to strictly follow what I discuss, but it's just a guideline. So that's why your feedback is very important, even after today's lecture. If you have any queries, concerns, please use that QR code. Send your feedback. We'll try to address them in the consecutive lectures as we go along, right? If there's anything which you want improved in your lectures, we still have another 4 or 5 weeks left, 3 weeks, I guess. This is your opportunity. And if there's anything you really liked and want to continue, you can also do that as well, right? So please use that feedback option as we go along. Okay, so now with that, I think we can focus on the topic for today, which is conceptual modeling. Any general questions before we get started with the content, right? It's not a lot of slides here, so we'll be able to finish the first section in the next 25 minutes. Okay. Our objective today is to understand and be able to describe what conceptual modeling is. Very important for a software engineer to understand and do conceptual modeling, right? We also need to know how it is different from a physical model. Anyone knows what's the difference between a conceptual and a physical model? Is the physical model the real product, or is it just a model like the name suggests? It's a real product? Okay, think about a house, right? So you want to build a house. What do? You can make a conceptual model of a house. You can also make a physical model of a house, right? And then there can be a real house. Now, I give you 30 seconds just to think about what the difference is. A real house, a physical model of a house, and a conceptual model of a house. Are they the same? If you can figure that out in the next 30 seconds, you know the lecture for today. You don't have to sit here for the next 25 minutes.
Conceptualizing the very first stage of like plotting or planning the thing out. Just kind of sort of like what the architect does basically for a house. Just create the design layout of the house and then
Yeah.
go forward.
So, yeah, anyone else wants to add to that? It's pretty much on the same, in the correct path. Conceptual is more like an abstract representation, maybe something which is not tangible, right? So you can't physically touch the model. It's something maybe on paper, right? So for a house, what he said, the architect or whoever can draft the plan of the house on paper about the dimensions and the roof structure, number of bedrooms, whatever. That's a visual representation on paper, right? So that's a conceptual model. Maybe in the next stage would be a physical model where you try to construct something but to a smaller scale to get a more better sense of how the house will look like and how the colors will blend together, how the views from the different angles, side elevations will look like. So that becomes a physical model of the house. And finally, it's your product, which is the actual house. Same thing happens with software applications. Can you give an example of a conceptual model of a software application? Yeah, can be, yes. Interface sketches you draw using different tools on paper. Right? Pseudocodes you write on paper. Those can be your conceptual models. Your database design, your ER diagrams. Right? We'll learn about straight diagrams today. So those are conceptual models. What about physical models? A little more tangible. Maybe a few functionalities built as a prototype. Right? So it's not the actual product. It may not look like an actual product, right? But it's something that the user can interact with, the interfaces and things like that, click here and there. So that can be something more than a conceptual model. And then your actual software application is the actual product, isn't it? So that's what we're going to look at today. We'll look at some common types of conceptual models. So a software has many parts, right? It's a data layer, it has interfaces, it has business logic. So we'll look at different models for each of those different components. And we'll also discuss why these models are important. Right? Who uses this model? Is it just the programmer who builds it? You mentioned about Swagger files, right? So the programmer maybe uses it, but it's more useful also for the tester, right? Who's a totally different person. Right? User interface designer might not write the actual code, so he's also a stakeholder. So who actually uses which conceptual model? That's also something that we'll look at. And also we'll focus specifically on state diagrams, right? And what they represent. We will do a few examples. This is one of the most important models for this course. There are others which are also useful. So yeah, those are the key objectives of today's lecture. So we'll start off again talking about what is a model. We have talked about it already. Anyone can give me a one-sentence answer. In the context of a software. Or maybe let's make it easier in any context. What is a model? Is this a model? Yes, it's a simplified scaled down version of our actual product, and its objective is to enhance understanding, communication, right? So back to this question, is this a model? Yes, model of a ship, right? Is this a model? The author claims it to be a mathematical model. Is it some kind of representation of something? Yes, between input and output, right? So how are these variables related, and how the input parameters can maybe reach a desired output, right? Which is modeled as a mathematical equation. What about this? Is it a model? Yes. What's the objective of this model? What is this person showcasing? Yes, we'll give it a try. Fashion, right? More specifically, how different components of a costume go together, the accessories, the shoes, the clothing, right? Now, the real product and how a human being behaves is more complex, right? The objective of this model or this person is just to showcase that particular maybe costume, right? And how the accessories behave or gel together. That's why you'll see they don't focus on smiling or dancing or creating some distraction, right? The focus will also always be on the product. What about this diagram? Is it a model? Yes, right? For the data layer, for a database, you need to understand the entities and how they relate to each other. For example, sorry for the clarity, but you'll see that it has the city and then it has a person, right? And it has a connection here that a city can be a birthplace of a person, right? That's how maybe how data is stored in the database. Here is department and a professor, right? And it says the professor belongs to a department. So it's a model to represent how data can be stored, right, in a database. What about this? It is a model of the atomic structure and how the different elements exist together, right? What about this one? Yes, it's a model of most likely a software, right? Which shows that the user can get view layer will provide some kind of feedback to the user. The user can input information into a software via the controllers, right? And at the back end, we have some persistence and business logic that operates on the input, right? Very simplified, abstract, early stage model of some kind of software product, but it can still be classified as a model, right? So if you put all these ideas together, we come to the definition that one of you have already given us. A model is a simplified representation of more complex system that helps us understand, communicate, and reason about that system. Right? So the key point is a model is there to reduce complexity. It helps us predict, analyze, and document system behavior. So it can tell us what will happen next, predict. For example, if there's an interface, a form, you click on this button, which window will open, right? So that's the next stage, predicting what will happen next. So the programmer or the developer can know what's the next step, right? It can also help us analyze and document system behavior, right? So you can make a Swagger files so that the system knows what will be the input and what will be the output. Right? And models are used, like I said, from the examples of the pictures we have seen, from many, it's used in many domains, maths to software to building aircraft or aerodynamics and so on. Why do models matter? Like I said, communication between stakeholders. So it allows the idea of all the stakeholders to put together in a common domain so that they can all agree that, yes, this is how the software should work, right? So before you build, which can be costly, it's good to first make a model. So when you want to build a house, maybe your viewpoint, the developer's viewpoint, maybe your partner's viewpoint, your children's viewpoints, all are put together. And then model helps as a means of communication that no, this room should be larger, the house should be facing this direction, the garage size should be extended, and so on, right? So that's what the models helps us achieve. Similarly, in a software context, the objective is still the same. Right? It also provides a reference for design and implementation. So whoever will later on design the product, design the software, implement the software, knows what to do. Right? And we also discussed that it helps us with reasoning. And also models are cheaper because once you build something, whether it's a house or a software, to change it becomes difficult. So it's better to see or get a perspective of how the components will work in a modular form as a model first before you go to that stage, right? Because reworking a software also not only delays your timeline, but also there's the financial cost and so on. So models are actually cheaper as well. Right? We also discussed this in the very first slide. Conceptual models are diagrams or visual representations, right? Now there are two types of conceptual models. One is structural, the other is behavioral. Structural model is about the architecture. So for a house, the structural model will give the dimensions. For a software, what will be the structural model for a software? Maybe the interface, the size of buttons, right? Maybe the color, the font of text on the page, right? The database structure, right? What kind of data will be handled? So that's your structural model, right? The different components or features, login will be there, maybe logout option will be there, registration option will be there, and so on. So these are structural models. Example will be UML class diagrams, which will not touch too much. ER diagrams, mostly covered in database courses. But we'll look at some of them briefly, I think, in the coming week. When we talk about behavioral models, we talk about how these different structures actually behave or interact with each other, right? So there can be events and actions performed. If there's a login form, that's the size, that's a dimension of the text boxes and the buttons. Those are structures, right? Behavior is, if you click on that button, what will happen next, right? What is the next state that will be caused by that particular action? To capture behaviors in a platform or a system, we look at state diagrams and class diagrams. So we use this in software context to describe workflows, right? And also to model the logic. Let's start with an example. Right? We have covered this already in a previous slide. So a behavioral model, these are some of the properties of a behavioral model, right? We'll start with behavior model first. We'll look at structural model later on. So it has distinct states, right? And then it has transitions which are triggered by actions, right? For example, when you log in, when you click on a button, that's an action that transitions you from a logout or guest user stage to a logged in user state, right? It changes your state. Maybe something simpler is a door, right? If you look at the door, all of you have been using it. So what are the different states for a door? Open and closed, right? So it's either open or closed. And what are some of the events or actions performed on the door? Right? Normally you'd say push or pull, right? But you can push from both directions, so it becomes confusing whether it's opening or closing. So we'll use the term open, close, right? You can open a door, open action, and you can close a door. Right? Now to represent that behavior, we can use some kind of diagram or notation. Right? Now there are variations all over in different literature, books, or the internet. The diagram structure we'll use is we'll use circles for our state. We'll use arrows or connectors for our transitions. So if I have to model a door, this is what it will look like. Right? Two states, closed and open. And then you can either open it or you can close it. Straightforward, right? So in summary, two states, there's two actions, open and close action, and the transition is from closed, you can go to open. From open, the action has to be closed to go to close, right? So if it's open, you can't perform the action open again, right? So that's why defining it accurately or representing it accurately is very important. Now the door also has a third state. It can be locked, right? If you want to represent that, so suppose the door has open state, closed state, and a locked state. What are some of the actions that can be performed? If it's closed, you can open it. So close to open. What else? Close to lock. So the action would be to lock it, right? And then lock to close, and then close to open, right? So something like this, right? So if you want to represent the state, now 3 states and 4 actions, right? You can't jump from locked to open straight away. First, when you unlock, it still changes the state from a locked state to a closed state. And then from closed, it will go to open. So that's basically what we want to learn today, is state diagrams or state transition diagrams. Any questions? I'll pause for a minute just to see if there's any questions on the online stream. Any confusion? I think someone has identified some interesting scenario. Would you like to share with us? It's a very simplistic assumption that we have taken, but is there something interesting you want to share?
No, it's good.
It's good, you're okay with it? Yes. Okay. Now, if anything that has a fixed number of state, we call it a state machine, right? So the door is basically a state machine, it's a fixed number of state. Likewise, when you build a software, it should have a fixed number of state, right? If it has some imaginary state which no one knows about and the software goes into that state, right, you are doomed, isn't it? So always when designing software, you have to plan what are the different states And how do we go back from one state to the other? You can't be stuck in one state forever. Right? You can't be logged in forever. You can't be logged out of the system forever. There has to be a mechanism to help you transition from one state to the next. Right? So a state machine has a finite set of states. It has transitions which are triggered by events or actions. And it also has rules that define how the system moves between states. Right? Like in our case, our rules were very simple, right? For example, these in brackets are just rules or guidelines that you can only transition from that state to that state using that action, right? So it kind of bounds the bounds the scenarios, right? So no one can jump from one state to the other freely. So we need rules. Now in softwares, we have the same thing. We have a lot of screens jumping from one screen to the next, login to register to this, right? If you're logged in, you can't go back to maybe creating a new registration, right? Something like that if the system doesn't permit, because you're already logged in. So those states has to be, situations have to be controlled. So when you design user interface, these transitions are the different screens that pop up, right? And to go from one screen to the next, for example, from log out stage to go to login, maybe the login button is the action that drives that, right? That transition. And the rule might be there has to be a valid username and password. Right? So login, logout flows, a common example in software. But when you say UI screen transition, there are other components or transitions that happen after you log in, right? Which has to be has to have rules and some events. Also, when you are dealing with network protocols, they also have different states. Your HTTP server is usually in a different state each time. What are the states your server can be in? It can be in a listening state. It can be in a responding state. It can be in a crashed state, right? Or shutdown. Or it can be in processing state, right? Processing user requests. So it can be in different state each time. And it's triggered by different actions and events. Likewise, when you build a game, right? You have characters. That character also is in a different state. Maybe he's just standing somewhere idle. You can have some action, some pressing some arrow keys, which will make that person transition from idle state to running state. And then from running to some other key press, which results in jumping state. So all these has to be modeled using your state transition diagrams. Now, just to understand it a little more detailed, just to make it a bit more complex, suppose you are designing this software for a parking meter, right? This kind of parking meter, there are different variations. Suppose for this kind of parking meter, where you may go and enter your duration of time you are spending at the meter, right? Sometimes because you have multi-level car parks, some of them ask you which zone you have, for example, parked, right? And based on the time, it gives you some calculations. So can you list or identify some states that the software developed for this meter will be in? And also think about some of the events or actions. Can be an exam question as well, right? Remember, 50% of your exam is theory, and this is one of the first few chapters or topics that are purely theoretical, right? Okay. Can you think of some states that this parking meter can be in? When you approach the parking meter, what state is it in? Idle, waiting for some input from the user. I guess that's a better right? Waiting for user input. Suppose you enter, I'm parking in zone A, then what does it do? It changes its state, right? Waiting for maybe the duration you want to park for, right? So 2 inputs it needs, maybe the zone you are parking in, you key that in, then it asks for duration. After that, what state does it go into? Yeah, yes? Payment. So it goes into the hungry state. It needs money, waiting for payment, isn't it? Right? So first input, then waiting for payment. Once you made the payment, maybe inserted some coins, checks if there's sufficient payment or not, right? And then what is the last state? Receipt. Right? It asks you to confirm, right? Confirm, okay, and then prints the receipt, right? And anytime you can cancel and go back to the previous or the earlier state, right? Or maybe go to the right to the beginning, where it was waiting for your entry for which zone you're parking in, right? In a maybe an expensive zone, maybe premium area, or just normal. So if we try to show that using a state diagram or state machine, fixed number of state, this is what it will look like. Right? First, you enter your parking bay, whether it's bay A, B, C, D, right? Premium or whatever. Then you input that number, that's your action. Then it asks for your duration. You enter 2 hours, then it's asking for the payment, right? Insert coins. Then sufficient funds is there. Then it gives you the confirmation button. Do you want to proceed, whatever? You say yes. It prints the ticket, waits for the next customer, right? However, there are times where you can cancel and go back to the previous state. You can enter the parking bay, enter duration, and then you say, no, I don't want to proceed any further. You go into the previous state. When you are making payment, if you are inserting coins, it goes into an iteration. It keeps reading more coins, right? Accepting more coins until you come to a situation where your payment is more than or equal to the parking fee. Then it asks you it goes to the next state of confirmation, right? If it's less, it continues asking you for more coins. If you don't confirm, it ejects the coin and then cancels, waits for the next customer. Right? Quite a simple example. Now, if you implement this, do you think it will work in a real life setting? Yes? Do you see any problem with this? I don't see any problem with this. It looks fine to me. On paper, it looks fine to me. But if I build this software and install it maybe in one of the car parks here, I think in 1 hour, people will start complaining. Why? Yes? Yeah, someone might maybe stuff in something else. Well, that's significant human error, intentional act of someone to crash or ruin the system or the platform. Well, that happens. But anything from my end which I can do to improve, what can be another very common issue that this software can encounter? What if you enter parking bay A, you enter the duration maybe 2 hours or 5 hours, right? And then you just leave the parking meter. You don't press cancel. So it will just hang in that state, wait in that state forever, isn't it? Right? It's like an exception scenario, right? Or you enter or insert a few coins, it says the parking fee is $8. You insert one coin, maybe $1, and then you just leave because you don't have more coins, you don't know what to do, right? Instead of canceling, you just let it hang forever. Will the next person be able to use the meter? No, isn't it? Because they are accepting or waiting for some input. So how can we solve those kind of scenarios? Right? So a very common feature is timeout. And when you build your um, application, if the Seva is processing something, right, and then there's a possibility that it can hang there for some time, it should time out, right? If the processing time has exceeded or for some reason the user has not provided all the right input, it should time out. In this case, if the person has just entered the parking bay number and the system waits for 5 minutes, which is I think too much, should just wait for 1 minute, right? No input, it should just cancel and go back to the previous state so that the next customer can use the parking bay or parking meter. Right? Likewise, if they are in any other state, like inserting coins, right, it should eject the coin and just cancel itself if there's not sufficient payment made within 1 minute or 5 minutes. Right? So timeout is an important component of software development as well. So keep a lookout for those kind of considerations as well. Right? Now there's one last activity before we take a break. I know that it's time for a break. So while we are having a break, maybe you can give this a try. Right? Suppose you can do it in pairs as well, and can be an exam question too. Model the Opal card system as a state machine. Right? So when you have your Opal card, I think I used one today. Oh, I left it in the office. So what state is that card in?
The card.
Yeah. Untapped. Idle. When you tap it, what state does it go on? It goes into maybe Janie mode or something, right? So it's active. That's why when the ticket conductors come around, scan it, it knows that it's not untapped, it is in a Janie mode or something. That's how they figure it out. Right? Sometimes it's untapped, but it goes into another mode, very common for students. Low balance mode, right? So now with that understanding, okay, these are the states that I'll help you identify, right? Ready mode means it's ready to use, it has sufficient balance. Active trip mode, which is the JNE mode, means it has been tapped on and you are in a JNE, right? And unless you tap off, it's still in active mode. Normally there's a timeout by New South Wales Transport where after X number of hours it taps off itself, right? So they have those timeouts there as well. And you have the low balance mode. So quite a simple example. And then when we talk about actions or events, these are the action and events. You can tap on, you can tap off, and you can top up. Now, with those nodes and the arrows, you can sketch up a state machine for the Opal card system. We'll take a 10 minutes break, right? Not full 10 minutes maybe, but it will give you an opportunity to catch up with some of the questions on live stream. And for you, if you want to just refresh yourself, we'll start in 10 minutes time. So we'll pause for now while you can work on those things if you want to, and I'll share the solution shortly. There's an interesting question in the chat, right? I'll just swap the slide for a moment to this one. And the question is, what if someone inserts coins first for the parking bay machine? As a developer of that software, what will you do? Yeah, so maybe there's a mechanism that will just eject the coins and you, on the screen, you will just show enter parking bay, right? So it might be just a hardware component which will not accept coins until you enter the first two input. Likewise, you might do that in certain cases in a software, right? A user might try to do something, enter maybe certain details first, um, which may not be permitted. So you might redirect them to the initial pages. And back to our example. Okay, another question in the chat is state machine, how is it different from a state diagram? Anyone wants to answer that? We use two terminologies. State diagrams, we started with that. And then we say any software or product that has a fixed number of state and the state are triggered or are states change or transition due to actions or events, and there are some rules that govern these transitions. Anything that is like that is a state machine. So a software, when you build a software, it has a state machine. Right? The parking meter example, it has finite states. Right? So in simple terms, not to confuse you too much, state machine is a product, right? And a state diagram is a representation of that product. Right? So a software is a state machine. To represent the different states of that particular product, we make a diagram, a conceptual model. Right? So state diagram is just a type of representation of an object or a software or some piece that has those qualities. Right? So state machine is basically a software or an object which has those properties, and then to represent that as a conceptually, we use a state diagram. Right? We can't represent the parking meter, I guess, in any other way if you want to discuss about state. So a diagram that suits that situation is a state diagram. There's a mention that state machines have rules. Well, definitely you have to have rules about how you transition from one state to the other. So anything that doesn't have a rule for transition cannot be properly represented in a diagram. Right? You can't have hanging states, right? Uh, if a diagram has a state which is just isolated, not connected, right? It doesn't have any action or events that can be applied. It basically means that there's something wrong with that state machine, that software, or that technology or product that you are representing. Okay, there's a question in the chat, and we resume now. For the Opal card example, I'm confused. What determines if you are in the low balance state? Right? So we're not implementing or representing any business logic here at the moment. We are just saying showing the transitions, right, of different states. So all you have to identify is from which state, ready, active trip, can you move into low balance state, right? And what is the event that can cause that? You can add a few more actions as well if you want to support that. I'll quickly now show the solution. It's one of the simplified solutions. Remember, there can be some variations depending on how you interpret, but based on what I have provided, right, you'll normally be in ready state, which means you have enough money all the time. Then you tap on, you get into active trip, where journey is in progress, and then that's when the conductors on the train or the bus might tap or check your card. And what they look for is the state of your card, right? If it's in ready or low balance, they know that you haven't tapped on. Active state, active trip means you have tapped on, tap off. There's some logic there, but we're not representing the logic in the state diagram. We're just showing the action, right? So the action is tap off, and it takes you into ready state. Now, from ready state, when it goes into ready state, maybe there's some business logic in that stage which checks as soon as you go into ready state whether you are in low balance state or not. So this doesn't explicitly need a user action. It has a system action, right? System initiated action which checks the balance and takes you into low balance state automatically. Or if that's not the case, it will keep you into ready state. Right? From low balance state, then it needs a user action to top up, and then you get back into ready state. So that's a very simplistic state diagram for your Opal card scenario. There are other diagrams which discuss the business logic, right? Which will not represent, we don't need to represent it in the state diagram. So in a state diagram, suppose the first one was an interface where you key in your username, password, and then your action will be login, and you go into the next state, which is logged in user. You don't have to say in the state diagram you have to check for username, password, verification and all that, right? Check for empty strings and all that. That's in a separate representation. Here you just show the transition of state. Just a high level visualization for understanding the different states. If there's one state that is hanging there on its own without any action or transition, it means there's something wrong with your software, right? Because if you go into that state, then you won't be able to come back. So the idea is you never should have a state like that. Right? So that brings us to the end of the first part we were discussing about models, right? So basically models are there to simplify complex system ideas. It has a key focus. So models basically allow us to gain better understanding. Right? We talked about two types of models, structural models and behavioral models. State diagrams that we are seeing now or just have seen about the parking meter scenario, the door scenario, the Opal card system, those are structural or behavioral models. Behavioral models. So they show certain interaction behaviors, right? And how they transition between different states. Structural models are more like the architecture. It's about the data stores, the mechanisms. If it's a house, then the dimension. For the door, we show the behavioral model, right? The open action, close action, lock action. If you make a structural model for the door, it will be the height, the dimension, the colors. Those are about the structure, right? Architecture of a door. Where is the lock placed and all that, right? But not those behavioral interactions. So today we just covered behavioral models. We looked at one specific type, which is the state diagrams. Now products or softwares that have a finite state, we call them a state machine. They have valid transitions, and these transitions have to be governed by rules. If all those three things are present, the different states, the different transitions, and the different rules, you can actually proceed to building a software then, right? If you don't have the rules, how to check for validation for logins, you don't have the layout of the interface, you don't have the transitions from login, where do you go, those information are missing, you can't proceed to developing a software. So this diagram plays a central role. So it helps you with design before coding begins. It also helps prevent mistakes, right? Which is quite obvious. You save time, effort, also cost. Right? So that ends our first part of the lecture. Any feedback, most welcome. We'll now transition to the next part, which is on authentication, which is very important in software development. Now, there's a question in chat before we move on to this about models, and the person is talking about the Opal card system. Just have to remember, real world scenarios are very complex, right? Like for the parking meter system, there can be people who can be just inserting coins before putting the input. Likewise, for softwares, people can be doing weird things, right? You enter trains, maybe the next action to come out of it, people don't tap off, right? So you can't model everything perfectly or expect everything to happen perfectly. So for certain things, the counter is to have timeouts and so on. But there will be other scenarios which may cause, inconvenience or things getting stuck in a particular state, and then you have to maybe intervene in a different way, right? So reset the server, restart the server, do something else, right? Or your Opal card gets corrupt because the sequence of actions were too complex. So real world is quite complex. Models are very simplistic representations. We try to capture as much as possible in our models so that our software and platforms work perfectly. But remember, no software is perfect, right? Even the best of systems from Google, Facebook, they have issues and bugs, right? Okay, I hope that answers the question on the chat. Now, let's focus on authentication. Now, what is authentication? All software systems developed these days have authentication mechanisms, right? Anyone knows what authentication is? Right, so it's trying to check or verify the person is whoever they claim to be, right? So are you really who you claim to be? That's what the software system is doing when they do authentication. The other thing we'll cover in today's lecture is when the user provides those credentials, username, password, right? How do we store those? Right? Because as a developer of a software, it becomes also your responsibility to ensure certain security mechanisms are there. Right? Sometimes hackers can hack into databases, but there are ways that you can ensure that even if the database is hacked, they can't use your password. Right? So how do you prevent that? So we'll have a look at that also today. Now, if someone registers on your platform, we look at what is the workflow for registration, right? What is the secured way of creating an account? You don't want to have duplicate accounts created or people overriding each other's accounts, right? So that should be also, we'll also look at that. Login workflow, right? When people are logging in, how do we verify the identity of a person? Also, there are many web pages in our application, right? You don't want them to log into every page. Once you log into one, you should be able to access the other pages, right? So how do you maintain user sessions? So that's also important. And then secure password handling, right? That means not only when you store passwords in the database, it should be secure, but also when it's sent over the network, right? It should still be secure so that no one can intercept it and use it. So we'll also look briefly into that under this topic of authentication. But first of all, these two terms are used interchangeably quite a lot, right? By many people, but they are not the same. They are related. Authentication and authorization. What is the difference? If you build a software, what do you do first? Authorization or authentication? Authentication. Okay, what is the difference between the two? Yes. So authentication is to confirm or verify someone's identity, and authorization is having permissions to access certain resources on your servers. So first thing you should do is always authentication, right? And then once you are identified as a potential user, do you have permission to access now the different resources? Right? We all can access Discourse, the forum, right? So we authenticated first, then based on our authorization, if I'm the lecturer, I can post announcements. You people can mostly post standard messages and reply to announcements, right? So based on these permissions, that's how the system controls who can access what. So in this course, we use the term auth a lot, right? When you have to implement a function for auth, it means for both authentication and authorization. And like we discussed, login, email, passport to verify the user, that process is authentication. Authorization, as rightly mentioned by one of our friends here, is when you determine whether the user is allowed to use certain resources or permissions to do certain tasks on the platform. Now, when you do register a user, this is basically what you do, right? First, you request for username password, right, to register a new user. Then you check if the user exists, because if someone is already registered, there's no use re-registering the same user, right? And then you store their credentials in the database, right? Anyone objects to this workflow? So when you implement our authentication function, registration function, that is what you should try to achieve. And then after the person is registered, then only you allow them to log in, right? And that is your authentication function. You check the user's credentials, or user enters the credentials first, then you retrieve their password, and then you compare if it's the right person or not. Right? If you have to implement this in normal TypeScript, It might look something like that, right? I haven't used a database. I haven't used a flat file system or a JSON file. Just use a data structure, uh, basically an array of users, and then each user will have an email uh, as the key value pair, right? So key will be the email, which is a string, and the value will be the password. Sorry. So when you register, like we discussed previously, we need the user to provide the email address and the password. First we check if the user already exists. If they do, true. If they already exist, you return false. Otherwise, you can return, create the user and then return true. While logging in, provide the credentials, right? You check if that user already exists, retrieve the password, compare with the password they have provided, then return true if it matches, otherwise you return false. Right? It's a simple implementation. Any confusion on that? Right? If you implement that, it will work, but there's a slight problem with that. We highly discourage this way of registration and also authentication. What is the problem with that? Password is restored? No.
Plain text password.
Yes, so it's plain text password, whether it's kept currently in memory, which is okay, but if it's stored in persistent storage, it's going to be problematic, right? So we are storing people's password, even though this application currently is running in using these variables in RAM, right? It's going to be problematic. So how can we actually hide the password so that when attackers maybe try to attack, or hackers can try to hack into our persistent storage, they're not able to retrieve that? Okay. So what we're going to learn now is what he has just mentioned, hash function. And we want to differentiate that concept with another concept that may have come into many of our minds, encryption. Can we encrypt the password? Or should we hash the password? Those are two different things. So we look at hash functions first, right? Secure your password using hashing, right? So what is hashing? It's using just a mathematical function or some kind of cryptographic function, and it converts password into a fixed length format, and it's one-way encryption only, right? So what it means is, if your password is ABC123, if you apply that hash function, it converts it from that to some kind of fixed format string like that. Right? And then it cannot be reversed back into the original password. Now this implementation is followed universally. So that our passwords, when we create, whether on UNSW accounts or any of the social media accounts, they are hashed, they are not encrypted. That means one-way conversion, and it can't be recovered. Now why is it implemented like that? Why is it not reversible? Or why should it not be reversible? Yes. So you agree with passwords being hashed. There are things like encryption where you encrypt something, so it scrambles things into another format similar to what hashing does, but it is reversible. So sometimes you want to send some message, like a WhatsApp message, that's encrypted end to end. So your message gets encrypted, but the other person still has an interest to read that message, right? They won't want to see those weird characters, so it gets decrypted, right? But that's not the case for passwords, right? So when you forget your password, you say recover password, you'll notice the systems never give you your password back. They ask you to create a new password because when you hash something, right, the security feature or the strength of hashing is it won't be, there's no mechanism to decrypt it or get it back. So even if the hackers, right, they hack into the database and they see your password like that, there's no way they can recover it in, or get it in the previous format, right? That's the strength of hashing. If it was reversible, we'll talk about hashing, encryption shortly, then the hackers will find a way somehow to decrypt that, right? Which is not ideal. That's why when you use passwords, we encrypt it. Now this hashing algorithm is so complex that even if you have a short, suppose input, goes through that same function, you'll see the output looks similar to even if you had a long password or a lot of text to encrypt, right? So it converts whether it's 5 characters or 50 characters into a fixed length, right? So there's no way to guess even from the encrypted data or hash data, that's the correct term, that it's a short password, it's a long password. Right? Likewise, if there's just a few changes in characters, so if you compare this to that, you see just the letter V has been switched to U, right? And you see the vast difference in what the encoding is. So it means if someone sees those two, they will still not be able to figure out that, yeah, these are very similar passwords, right? Or just a slight change in the positioning of the letters. And you see there's no way to figure out any resemblance, even though all the other characters are the same. Right? So that's the advantage of hashing. Right? When we talk about encryption, right, it means that you convert that plain text into a ciphered text, similar to what you have seen for hashing. But the problem is hashing, the output is fixed length. For encryption, it's not going to be fixed length because some documents can be short, some can be large, so it can vary in length. And the other major difference is, like I said, it can be reversible. So what the encryption code does is it uses a key, which is a private key of the receiver, and encrypts your plain text into ciphered text. When the information reaches the receiver, they use their own key to decrypt and they get back the plain text. Right? So they reverse the process. So there are scenarios where you want data to be decrypted. For example, if you are using a credit card, right, and you enter your details online on your browser, it has to be encrypted, but then when the payment gateway handles it, it needs to decrypt it so that it knows what your card number is, PIN is, right? Over the network, you want the encryption, but on the other end, you want the decryption. Likewise, if you want to send messages, right, or some confidential documents, you want it to be encrypted, but you want it to be reversible. So remember, there's a major difference between encryption and password hashing, right? Encryption is reversible, hashing or hashes you cannot. Now, how do we encode data and how can we hash data? So we'll just see a quick example. So that's the next part that I will demonstrate, and you can see that in action. So to do that, we'll need a crypto library. Now you don't have to install this; it's already built into Node.js, right? We'll just use it straight away. So this is what the code looks like, and I will demo to you if I have time. So you just import that library, and then there's a function that takes a string, and then using that string, which can be a password, for example, it creates a hash. So there are different hash encoding algorithms, right? One of that is SHA-256. There are many variants of it. right? We have SHA388512. There are other hashing algorithms as well. Argon1, there are other famous ones as well, right? So you can actually use those to create your hash. So what it does is it calls that function, you passes it the algorithm to use, and it updates your plain text, right, which you provide, and then you can format the output, right? Whether you want it in binary, you want it in hex, you want it in base 64 format, it will display the output in that format. So this is a simple example. It's already on the course GitLab code lecture section where you can try it out. But since we have a few minutes, let me just see if I can just show that the code actually works. Right, so I go to documents, COMP1531, ls. Okay, let me open 7.2. Right, so while this is opening up, there's a question on the chat on the live stream. When we encrypt password, someone can decrypt it, so it's not useful anymore. You can be hacked into. That's why we said when you implement passwords, right, or authentication for password, don't do encryption, use hashing, right? And here's an example. Sorry, it didn't open correctly. Code 7.2 Auth. Sorry, yeah. So here's a crypto function which I just showed on the slide. Right? This is the implementation. Output is in hex format. I've created a message which is just secret password. You can type anything. Create the hash of that, and I'm just going to display that. So npm run tsx hash.tx. Right? So you see that secret password has now been converted into this particular fixed format, which is in a hex format. I can just change that to password 1, and you see that the hex generated is very different now. Starts with letter C here, it starts with letter B, right? Even though there's a slight generation. And there's no way to recover your original password back using this hash code, right? I also mentioned that there's other formats you can use. You can use base 64, which is also a common format, right? So it's a slightly more compact variant. So sometimes over the internet, you don't want to waste so much bit space or byte space, then you can use a much more smaller version or more compact version, right? So you can play around with that. Likewise, you can play around with the encoding for the password, right? So this is the hash function. So now the question becomes, if you look at our original code, right, so when we look at it, right, this is what we used to do. If we have to implement hashing, where will we implement hashing? At which step? Before it stores, right? So in registration, before it stores, so between 2 and 3. What about in the login stage? Again, between 2 and 3, right? The only thing is in the login, once you retrieve the password, it should not be the normal password, it has to be the hashed password, right? So here's the improvement, right? So you do the same thing, only thing is you hash the password before storing. Here you retrieve the hashed password and then whatever password the user got, right? Because when you retrieve your hash password from the database or the file, You can't compare it with a plain string that the user has entered, right? They have to match. And you can't convert it back to the original string. So what is the safe way or the best way or the only way is whatever original string the user is entering now, you convert it into hash and you compare the two hashes, right? So that's the implementation. So you'll see that when you register, you are checking for email doesn't exist, and then if it doesn't exist, you set the password for that corresponding email. But before you set it, you don't just assign the string, you get the hash of the string, and that becomes the password to be used. When you recover, when you are logging in, you compare the hashed version of your password with the password that already exists with you, right? So those are the slight changes. But what it does is big impact. It makes your passwords more secure, right, when you are storing. Any questions? The code is already available. You can run and play around with it. Due to time, I will just move on to the next bit. Just to quickly compare encryption and hashing, right? So we know that encryption is used, it's important, but it's normally for data, right? And when you use hashing, it's mostly or solely used for passwords. Reversible encryption, yes. Passwords, for hashing, no. Output changes if same input is used. So when you do encryption, if I encrypt this file A and file B and both have the same content, the encrypted version will have the same. We decrypt, we get back the same output, right? But for password, do you think hashing will generate the same? In our current implementation, yes, it will, because that's how we compare the two hash, right? What's on the database. But there's a way to work around that. There's something called salts in hashing. So what you do is you assign a randomly generated string to the password, and then that string is allocated to that user, and that is hashed. So what happens if my password is 123, but my string will be different from your password, even though it's 123, right? So if both of us have the same password, the string assigned to me will be different, the string assigned to him will be different, so our hashes will become different. The benefit of that is, if your password database is hacked, the hacker won't be able to know that, oh, these two passwords are the same, right? Because the hashes itself will be different. Now, how is that salt generated and handled? There's maybe an additional lecture on that. Courses also discuss that. But what we do is, when we generate a password with our account or email, that random string is also assigned or saved. So that's always kept with us, right? So there's no way my random generated salt will be same as yours. So when we store the data, for encryption, we need to know the encrypted data, but also the key to decrypt it, which is the private key. For passwords, we just need the hashed password, plus if you have more security built using salts, then that can be some additional information that is stored in your user account. But that's just a random string. By no means will it be useful to a hacker, because like I said, the hashed version will never be able to be decode the password, right? It's just there to generate that hash and is assigned to your account to maybe verify later on if the same password is entered with that hash combination, salt combination, that the passwords match. But it's of no use to anyone else, right? And encryption, like I said, used for files, messages, HTTPS traffic. Passwords, only for authentication. Sorry, not passwords. Hashing, only for authentication. Right? Now, apart from passwords, there's something else that is needed when we communicate with the server. We need to have some session information. Otherwise, if this information is not there, the user will have to log in multiple times every time they visit a new page, right? Now, this information is encrypted, right? Because it doesn't contain the password, it just has roles, permissions, and expiry timestamps, right? Now, these information, how does it get to the server each time you make a request? Through the headers, right? Now, we use HTTP headers. We don't use the body because we have already learned before that some methods like get and delete, they don't have a body component when you make a request, right? Only put and what's the other one? Post. Those have a body component. Right, so these are the two ways in which we can handle our user tokens. Not very important, so I have got some detailed text here just for reading purpose, but we don't have to worry about it too much, not for the exams as well, so that should be fine. So with that, that brings us to the end of the lecture. Just quickly summarizing in a minute, remember authentication, authorizations are two different things. Authentication comes first, then you check for authorization. Both are essential. So whenever you implement a login system, make sure there's authentication, there's authorization. Encryption and hashing are two different things as well. Encryption, you use it when you want to get your data back. Hashing is when you're not interested in the data again, in the sense that you don't want to recover it to the original format. So it makes or suits the use case of passwords, right? Hashing. Now, if you want to focus more on security, tokens, authentication, authorization, there's other cybersecurity courses which can help you. Now, with that, that brings us to the end of the lecture. Please provide your feedback. Any ways we can improve. We still have 3 more weeks to go. Anything else you want to see in the lectures? This QR code provides us or becomes the mechanism to gain your insights. So take note of that. Now, before I end, just 30 seconds of your time, maybe not of interest to everyone. I mentioned that there was a request from one of the students from their feedback forms that they wanted to know how do you do coverage test on our HTTP server, right? So I'll just close this. On the course code section on GitLab for the lecture, if you do go to 7.1 examples, right? So what I've done is I didn't want to create a new example because that will help confuse you people more. But there's a library called Supertest, right? Which you can use to test requests or endpoints. So to do that, you can install that library. I've put the code here, npm install jest supertest, right? The whole dependencies of that will be saved. Now, to test it, the book library looks the same, right, as it is. Yeah. Only thing is, at the end, I've exported the app, right? So app is basically the application object of our server, right? So we create that express server, remember, on top. Here, the rest of it is the same, read books, write books, and so on. These are our endpoints. Now, in the test file, you see I have just imported, this is just an alternative way of importing libraries and files. So I've just imported this supertest. I've also imported the book library because that's the server which has the endpoints, right? Now, I've created some test cases for you people to try out. You can, for example, test the GET request, right? And you can check the response status code, which is very important in HTTP request. Now, when you do request the books, right, what happens is the GET method here retains an array of books because we have a lot of books in the library. So it retains an array. So my first test is just checking if the result is an array. True, right? If it matches, I'm happy with the test. Then I check the length of the array. Are there 2 elements, right? So that's how I'm checking the test cases. If I just run this npm run test books library, test, right? So it passes the test, right, for this one, where I just want to get an array as a result. If I want to look up a particular book in the test, here's a test, and I'm defining how the results will look like, because I want to check if it is exactly the first book with ID 1. So Hobbit, whatever. I just do save. I run this test, right? 2 tests pass. So likewise, I have a post request. I have a delete request. In your own time, give it a trial. I hope the person who posted that question has some reference now to work with in terms of how to test HTTP server remotely, right? So this is just an example. It's already on the code section. You can play around with it. Maybe you won't directly want to use it in your iterations yet, but this is just an alternative way to test, a very simplistic way. So with that, we'll round up the lecture today. Thank you very much. From next week, there will be a different lecturer. So all the best with that. For me, I think the best you could do is probably provide some feedback on how things can be improved, or how things, what went well with the course. So thank you very much, and see you maybe in week 10 again. Thanks. The questions in the chat, I will try to respond to those over the next few days. Thank you.